All right, today we're going to talk about one of the most important inventions ever. Seriously, we're diving into the Bipolar Junction Transistor, or for short, the BJT. This tiny little component is so powerful it basically kicked off the entire electronics revolution we're living in right now.
And I'm not kidding when I say it's everywhere. You can't see it, but its DNA is in your phone, your computer, you name it. Think of the BJT as the granddaddy of all the integrated circuits that run our world. Without this little guy, the phone in your pocket, the laptop you're watching this on, they just wouldn't exist.
So what's its secret? Well, at its core, the BJT kind of has a split personality. You give it a little nudge with a signal, and boom, it acts like a perfect wire, a conductor, letting electricity flow right through. Turn that signal off, and it becomes a roadblock, an insulator, stopping the flow completely. This on-off trick is what makes it the perfect, super-fast electronic switch, and that, right there, is the bedrock of all digital logic.
But wait, there's more. That's just its digital side. In the analog world, it has this other superpower. The BJT can take a tiny, weak little signal and make it huge, way, way stronger. That's called amplification, and is absolutely essential for things like your stereo system or picking up radio signals.
So, how in the world does this one little component do all of that? Well, to figure that out, we've got to look inside. The best way to think of a BJT is like a really, really carefully made three-layer sandwich of special semiconductor material. These three layers have some pretty cool names: the emitter, the base, and the collector. And honestly, their names tell you exactly what they do. The emitter, well, it emits or shoots out the charge carriers. The collector collects them on the other side. And the base? That's the super thin layer in the middle that acts as the control gate for the whole operation.
Now, this sandwich comes in two main flavors, NPN and PNP. All that means is what kind of semiconductor material they used for each layer. For NPN, you've got a P-type layer squished between two N-type layers. And for PNP, you guessed it, it's the other way around. In NPN transistors, the things doing the moving are electrons. In PNP, they're what we call holes, which is just a fancy way of saying a spot where an electron is missing, which creates a positive charge that can move around.
Okay, now this is really important because it's a super common mistake. You look at it and you see these PN and NP layers and you think, oh, it's just two diodes stuck together, back to back. But no, it's not that simple. The real magic happens because the transistor is built as one single continuous piece of material. The regions are so close they can influence each other in ways that two separate diodes just can't.
And this table just lays it all out beautifully. You can see how each part is specially engineered. The emitter is heavily doped, meaning it's packed with charge carriers ready to go. The collector is really wide, so it can catch all those carriers and handle the heat. But look at the base. This is the secret sauce. It is incredibly thin and very lightly doped. That specific design is the key to how it controls everything.
So because of this clever internal structure, the BJT is super versatile. By applying different voltages to it, a process we call biasing, we can switch it between three totally different modes of operation. It's like giving it a completely different job to do.
And check this out. This table breaks it down perfectly. When we want it to be an amplifier, we put it in the active region. But if we want it to be a switch, we use the other two modes. In the cutoff region, everything's off. No current flows. That's our off switch. Then there's the saturation region where everything's wide open, maximum current is flowing, and that's our on switch.
Okay, so let's get to the coolest part, the amplification. How does it take a tiny signal and make it massive? To really get it, let's follow the flow of electrons inside an NPN transistor when it's in that active region. This is where the magic happens.
So, picture this journey. First, the emitter does its job and just shoots a massive flood of electrons into the base. Now remember, that base is super thin and doesn't have much for the electrons to interact with, so most of them just zip right across it. Only a tiny little trickle of electrons actually leave through the base terminal. That's our small base current. The rest of them, and we're talking like 99% or more, get swept up and grabbed by the collector, and that becomes our huge collector current.
And this whole process is perfectly balanced. It's all governed by a basic law of electricity. Just think of it like a river of current flowing from the emitter. It splits into two streams, a tiny one flowing out the base and the main river flowing into the collector. It's simple, really. What goes in must come out, so it all has to add up.
So, after all that, what's the big takeaway? Let's boil this all down to the single most important concept you need to remember about the BJT.
So just how much amplification are we talking about here? Well, that relationship is defined by a number called beta, which is the current gain. And for a typical transistor, beta is huge. We're talking anywhere from 50 to 400. That means for every 1 electron we push through the base, we get to control a flow of 50 to 400 electrons through the collector. That is some serious leverage.
And this right here, this is the aha moment. It's like you're using a tiny little faucet handle, the base current, to control a massive fire hose, the collector current. The tiniest little adjustment to that small base current creates a huge proportional change in that much larger collector current. Which brings us to the formal definition. At the end of the day, a bipolar junction transistor is a current-controlled device. A small input current controls a large output current. If you remember anything, remember that phrase. It is the key to the entire thing. And just to give you some context, the BJT's main rival, the field effect transistor, or FET, works on a different principle. A FET is a voltage-controlled device. With a BJT, it's all about current controlling current.
It is just incredible when you stop and think that this one simple idea, a small current controlling a large one, is the engine behind our entire digital age. From the simplest little blinking light to the most powerful supercomputers, it all comes back to this. It really makes you wonder, what's the next tiny little component that's going to change the world?